So fortunately, your turkey was successful, right? Because we saw in the last problem that our turkey was done at 165 at about 4:30 in the afternoon. But you realize after the fact that your mom's model was incorrect due to the difference in the size of your respective turkeys. At 1 p.m., your turkey was 40 degrees, and by 1:30, your turkey had heated only to 52 degrees. On her timeline, on the last problem, her turkey was at, an hour later, was 105 degrees. So your turkey's definitely not cooking as quickly as your mom's turkey did. So it says if you buy the same size turkey next year, what model should you use if you still plan to bake it at 425? So we can actually build the model off of the two data points that we were given. So if we want to build the positive temperature difference by hand, we can use the initial value time the value measured some in time later divided by the initial value raised to the t over n. And so we actually saw this in the last section when we were building exponential models off of two data points. So at time 0, your turkey was 40 degrees. And then a half hour later, so at 0.5, because remember we're measuring t in hours, so I need to convert this to hours, your turkey was 52 degrees. So in order to build this model, remember I have to adjust my y values by taking the temperature of the oven, 425, and then subtracting that from it. So the first value we're going to use is 425 minus 40, which is 385 degrees. Then a half hour later, it's 425 minus 52 degrees, so 73 degrees. So we still have to adjust our y values just like we did with the data set. So now the positive temperature difference is 385 times 373 divided by 385 raised to the t over 0.5. The actual model for the turkey says take the temperature of the room and then subtract this model from it. So this is the model we should use if we want to try the same experiment the following year. So if we use this model, how long now will it take the temperature to reach an internal, or how long will it take the turkey to reach an internal temperature of 165 degrees? So we're going to come back to our calculator, and in y equals, we're going to delete the previous model, and we're going to type our new model in. So 425 minus 385 parentheses 373 divided by 385, close the parentheses. Now when we raise it, we need to open another set of parentheses because we need to make sure the x divided by 0.5 all ends up in the exponent. And then we're going to check the temperature at 165 degrees. So our window should be okay for this. So now we're going to find the intersection. And it looks like t is 6.2 hours. So it will take about 6.2 hours for the turkey to be done. So if you start the turkey at 1 p.m. again, then what time will the turkey be done? So we know that 0.2 hours is 12 minutes. So 1 p.m. plus 6 hours is 7 p.m. So at 7:12 p.m. the turkey would be done. So you can actually do calculations like this. If you know you want your turkey to be done at a certain time, you can calculate how long it's going to take to cook and then back up the start time. And then you always want to add a little bit of time to make sure, just in case it's not done, your dinner's not delayed, right? You can always reheat the turkey if it cools off after you pull it out of the oven.